Hello everyone. In this lecture we discuss about memory organization or memory segmentation of 8086. First of all, we know that in a 8086 microprocessor there are 20-bit address line. 20-bit address lines are required to realize 1 megabyte memory access. So we know that what is the length of the 1 megabyte memory. So the 1 megabyte memory length is from 00000 hexadecimal to up to FFFF 5F hexadecimal. Okay, so now this is the length of the 1 megabyte memory, but one problem arises. Why? Because internally in a 8086 microprocessor all registers are 16-bit. So now we know that 16-bit registers, that means total combination 2 to the power 6, that means 64 kilobyte length of each segment, memory segment. Okay, so that's why 2 to the power 20 divided by 2 to the power 16, that is 2 to the power 4, that is 16 segments are available in this memory, in the 1 megabyte memory. Each on segment is represented by 64 kilobyte. Each segment is represented by 64 kilobyte. So that's why the segmentation is very important in 8086. Okay, so first of all, the segment register value into offset plus IP value or base index value or source index value determine the actual memory address in the 8086 microprocessor. And the memory is logically divided into 4 segments: code segment, data segment, extra stack segment, and each of length is 64 kilobyte, and they are both 4 segments can partially or fully overlap to each other. So now we draw the diagram. Say for example, this is a 1 megabyte memory. Okay, here available of 64 kilobyte memory. These are 64 K memory of code segment. Okay, say for example, and this is a continuity of memory, and there is a 64 kilobyte another memory which is known as SS stack segment, also known as stack segment memory. And here mention that the data segment, this part, this another 64 kilobit part is known as data segment also, and extra segment also. So see that here extra segment and data segment are fully overlapped to each other. Stack segment and data segment and extra segment are partially overlapped, and code segment are separately. So now they are the 16-bit registers: code segment, stack segment, data segment, and extra segment. So now this code segment is located to here with the offset value, this offset value, and point out the last location, for starting location to last location. Stat segment is basically used for this location, data segment for this, and this extra segment for this. So now the memory length is for FFFF, the last address, and the starting address are starting from this memory location 00 hexadecimal location. So here in the figure show that the code segment is separately defined, whereas stack segment is partially overlapped with the data segment and extra segment, and data segment and extra segment are fully overlapped to each other. Okay, and this is done by loading the same value in the data segment and the extra segment registers, and that's how the 16-bit memory address is converted to 20-bit memory address. Okay, so now we discuss about something about assignment of segment register for the types of memory references. So here we discuss assignment of segment register. So here we discuss about type of memory reference. Okay, then default segment base. Okay, this is a column 1, column 2, the alternate segment base is a segment. Okay, and last one is offset. What are the offset are used? First of all, use instruction phase. For this, code segment is used, and no non-alternate base, and instruction pointer is a offset value. Next, for stack operation. Okay, for the stack operation we know that the stack segment is used, and this is none, and the stack pointer is located for the offset value. So stack operator, these are stack segment 16-bit register is the perform stack and by this stack pointer we can varies this memory location from initial to the final destination point. Next, variable. Next, for the variable, what this is data segment is used because variable is a data segment, and for these also be used for this purposes, and this is for effective address. This is for an effective address. So there are lots of features are available for the memory references. There are also string source are available, string which is for DS also allow, and this is the same, and for this source index is basically used. Okay, so just a minute. Okay, so this was string operation, and next one is for discuss about is a source index last. Okay, next we used BP base pointer or base register. These use text segment and code segment, data segment, yes, and these also for effective address. In the when we execute the instruction, then this is thoroughly discussed in this session, because this is very important for memory segmentation. It is not very easy task to generate the base address to the logical address, and therefore using this segmentation method we can address 1 megabyte memory with only 16-bit registers, and we will have separate area of code segment, data segment, stack segment. We can also relocate a program by simply changing the content of the code segment register value. The program can work several data sets by reloading data segment registers also. And though microprocessor or 806 16-bit microprocessor, still memory is in 8-bit wide. Each memory is 8-bit wide. This is because two reasons. Number one, because in the memory each register content is 8-bit. Okay, because there are two reasons. Number one, most of our IO devices is 8-bit, and number two is there are many instructions which are of 1 byte. The other instruction are form of 2 or 7 bytes. So by being able to access individual byte, this odd length instruction can be handled. So that's why there are partition of 2 8-bit. So all memory locations are given by 20-bit address lines, but each of memory is represented by 8-bit register. The data bus are 8-bit, not 16-bit. Okay, the memory address line is 20-bit. Okay, so this is the discussion in this lesson, the memory segmentation method, and different types of memory and types of memory references and their default base address, and then we discussion about the IO port selection. That's why the each memory address or each memory register is a 8-bit length wide. Okay, that's all for today. Thank you.